Okay, it is my hope that you're getting more familiar and you're getting faster and better at this as we go on. Let's try number 9. So for this one, I'll work with you. Okay, so for number 9, the more complicated side is 100% the left side. So let's draw our dotted line down the middle. And I'm working on the left side. Now the first thing that draws my eye, and probably yours too, is this. And I'm thinking, is there a formula for that? So I'm going to go up and check if there's a formula. Cosecant plus secant. Cosecant plus secant. So cosecant squared is here, secant squared is here. Unfortunately, they're not in the same formula, so I can't replace that with any easy fix. So that's a no-go. But let's see what else we can do. Perhaps we could rewrite these, right? If all else fails, we could always rewrite everything into sine and cosine. Because that'll give us always the best chance to cancel things out and simplify. So let's simplify the left side like we did yesterday. So sine squared theta will stay the same. I don't need to change it because it's already sine. But these guys will need to be rewritten. Cosecant is the reciprocal of, do you remember? If this guy starts with a C, what's its partner start with? Yep, an S. So this is going to be the reciprocal of sine. And there's a squared here, so don't forget to write sine squared theta. Bringing down the plus sign. So what's the reciprocal of secant squared? If this guy starts with an S, then its reciprocal starts with a C. So this will be cosine squared theta. And the right side, I'm not changing anything at all, leaving it as is. Okay, now that we have this set up on the left, you might be thinking, oh my gosh, Ms. Nami, that's more complicated. What are you doing? Don't worry, it'll work itself out. Now I'm going to distribute my sine squared. Because look, I'm already seeing a potential to cancel here. And let's just see what happens. If it doesn't work, we go back and try something else. There's no harm in trying things that don't work. So when I distribute, I'm going to put this over 1, multiply straight across. So first, let's multiply this times this. Sine squared theta times 1 is sine squared theta. 1 times sine squared theta is also sine squared theta. Great, now let's distribute to the second term. So we're multiplying the outside guy with 1 over cosine squared. So tops multiply, and then we multiply straight across. So it's going to be positive. Sine squared theta times 1 on top is sine squared theta. On the bottom, 1 times cosine squared is just cosine squared theta. And that's supposed to somehow, I don't know how yet, but somehow it'll equal secant squared. Don't lose faith, stick it through. So what can we do now? Well, what can we simplify? On the left side, sine squared over sine squared just becomes 1. So I'm left with 1 plus, and sine squared over cosine squared, well, that looks awfully like my tangent formula. Except these guys both are squared, right? Sine over cosine is tangent. But sine squared over cosine squared is tangent squared. Yay. So we are getting somewhere. Darn. Weird things are happening again. Okay. So equals secant squared theta. Now we have to prove the left side equals the right side. Hint, scan your formulas. Let's go back up and look. Is there any formula that involves tangent and secant? Yes, sir, there is. Tangent, formula number 2 says 1 plus tangent squared is the same as secant squared. So anytime I see 1 plus tan squared, I can just write secant squared in its place. Well, how very convenient. This is 1 plus tan squared, so I can replace it with secant squared per formula 2. And now I have proved my identities. So today you're seeing that these problems can get just a tad more complicated, but they also get more fun because they require a little more creativity, and they require you to also kind of be brave and try new things. So this is definitely not the only way to solve this problem, but it's one way that you could try. As long as you stick with the formulas and general rules of math, any way can work. There's probably like 10 ways to do this problem, which is awesome. Okay, number 10, do this one yourself. So this is like a level 1 problem, okay? It's super easy. I just want to bring you back into the groove after, 24 hours. Choose the more complicated side. So this time, the more complicated side's on the left. Hopefully you replaced, not both of them, but just secant. You should have replaced it with 1 over cosine theta. You should have left cosine theta the same because we use our strategy to rewrite everything in terms of sine and cosine. So put this over 1 so that we can multiply straight across. And notice the cosines cancel, leaving me indeed with just a 1 on the left equal 1 on the right, and we're done. Let's try number 11. Okay, pause the video, try this one on your own. So when you chose the more complicated side, for me it looks like the more complicated side is on the left because there's division, there's also something being squared, and there's a secant. And I know that secant can be rewritten as 1 over cosine. So for all those reasons, I'm going to work on the left side. So let's replace tangent squared. Let's just rewrite it. And secant, let's rewrite it as 1 over cosine theta. Now, some of you are screaming at me right now. You're like, Ms. Nami, what are you doing? And I just want to show everyone what could happen if you don't make the right move right away. So notice nothing cancels. You don't have anything on top that's the same as anything on the bottom. And that's okay. If you get stuck like this, I want you always to go back to our winning strategy. Rewrite everything as sine and cosine. So just like how we rewrote the bottom using yesterday's formula as the reciprocal of cosine, we should also rewrite the top. Tangent is sine theta over cosine theta. So let's write that. Tangent is sine theta over cosine theta. But it's also being squared, so let's not forget to put sine squared over cosine squared. Okay, I'm going to, now I have a fraction divided by a fraction. So the way that we handle complex fractions like this is copy down the numerator and then multiply by the reciprocal of the denominator. Well, what do you notice happens now? By the way, I'm just copying down the right side. I'm not doing anything with it. We need to bring it down every step. So what do you notice now on the left? Well, I notice that cosine cancels with 1 of the cosines down here, leaving me with 1 cosine on the bottom and no more cosines on top. So my new left side says sine squared theta over cosine theta. And the right side still doesn't look like it. Darn it. But that's okay. I want you to be a little strategic. How could we make the left side look like the right side? Or, if you're feeling adventurous, how could we change the right side to look like the left side? You can work on either one. So first, let me show you without breaking the rules. We could actually rewrite sine squared as sine theta times sine theta all over cosine theta. And from there, we could rewrite that as sine theta over 1 times sine theta over cosine theta. Convince yourself that sine times sine would give me sine squared, and then cosine times 1 would give me cosine. So these are actually the same. Now, why did I break it up like that? Because I knew I needed a sine all by itself. Boom. So see, I'm using the right side to kind of guide my actions. So I knew I needed a sine all by itself. There it is. And then I knew I needed tangent theta, which is sine over cosine. So now in my final step, so this is how it was. So in my final step now, the sine is going to just chill off to the side because I need it here. And then for sine over cosine, I can rewrite that as tangent theta. And so I'm showing that I have succeeded by writing my check mark. We verified the identity. Now, if you did it a different way, you didn't have to break up the left side like that. By the way, pause the video, rewind it if you're copying down and I'm skipping ahead. The nice thing about videos is that you can rewind at any time, so do that for sure. Let me show you if you decided to work on the right side, what that could have looked like. So let's say you were a rule breaker, okay? You're a true rebel. And like you eat garlic before dates, and you touch people after eating hot Cheetos, like gross, okay? You're a rebel is the point. Well, we could have replaced sine and tangent, or actually just tangent, in terms of sine and cosine. So since sine is already sine or cosine, I'm going to leave it. But tangent, I can rewrite it as sine theta over cosine theta. Now I'm seeing I have a multiplication problem, so put this over 1 and multiply straight across. So this time the left side is going to stay untouched. And now I'm working on the right side instead. Well, sine times sine is sine squared. And 1 times cosine is just cosine theta. And oh my gosh, would you believe it? It looks exactly like the left side. So we could have verified it that way by manipulating both sides of the equal sign. So if you're feeling daring and adventurous, you can always do that. All right, that was number 11. Let's see number 12. So as always, I'll give you a chance right here to pause the video and try it on your own. Okay, so if you gave it a shot, let's see what happened. And definitely we're going to work on the left side. It's way more complicated. Drop your dotted line to separate your work. Now, I'm just going to go ahead and replace everything with sine and cosine. So cosine and sine right here, they're already good to go. But tangent, I can rewrite it. So let's go and rewrite that. The tangent formula is sine theta over cosine theta. And all that complicated left side is supposed to somehow simplify to a simple, humble little secant. Let's see how the heck we're going to make that happen. Well, the first thing I'm noticing is there's a lot going on here, but at the end of the day, it should only equal one expression. So what that tells me is that this fraction here needs to be added with cosine. Like I need to actually combine those. And the only way that we combine fractions is by finding the LCD. So you're saying, okay, Ms. Nami, I don't know what you're talking about. Sorry, I'm jumping the gun a little bit. Let me show you what I mean. So let's handle this guy over here. It's sine times sine over cosine. I'm going to put this over 1 and multiply straight across. So we got cosine theta plus my new numerator, sine times sine, gives me what? Yep, sine squared theta. And then the denominator becomes what? Cosine theta. And that's going to equal secant theta. Not touching anything on the right, just bringing it down. If I need to combine these fractions, because clearly I need to make it into a single term. So how do we always add fractions? What do we need to find first? Yeah, we need to find the least common denominator. Well, the cosine just has a denominator of 1, so we don't even need to worry about that. Then that means the least common denominator is going to be cosine theta. So if I need both sides to have a denominator of cosine theta, the right side is good to go, but this left piece needs a cosine theta in the denominator. How will I give it one? By multiplying the bottom and the top. So now I have on the left cosine times cosine, which is cosine squared theta, all over cosine times 1, which is just cosine theta. By the way, convince yourself that cosine squared over cosine really is the same as just cosine, right? These would cancel, leaving me with, so they're equivalent. Plus, on the right side, I have sine squared theta over cosine theta. And look, this is amazing. Why am I so excited? Well, I'm excited because now we have the same denominator and I can add my fractions. How exciting! So cosine squared theta plus sine squared theta will be my new numerator. And because they have the same denominator, I could do that addition now. So they're all over cosine theta. And the right side, by the way, is secant theta the whole way through. Okay, now that we've reached this step, see if you can finish the problem yourself if you didn't earlier. So hopefully we've done enough problems by now that this top guy here is just screaming at you. I am one of the Pythagorean identities. It's identity number 1. Cosine squared theta plus sine squared theta equals 1. So all of this turns into just the number 1, which is pretty amazing. The right side still says secant theta. Once you get it to this step, finishing is as easy as remembering that 1 over cosine theta, aka the reciprocal of cosine, is indeed secant. So now I'm going to replace the left side with one of yesterday's rules, which is 1 over cosine is secant theta, and the right side is still secant theta. And we are done. I'm just going to make it a little smaller so you can see the left and the right side all the way down. Yeah, so there we go. We're done. Okay, we still have one more problem to do. I want you to do it on your own. And then we'll have this bonus problem for those of you who are like, this is pretty cool. I want to try a harder one. So try 13 right now on your own. How many? So I see 1, 2, 3, 4 trig expressions. We have tan, we have cotan, cosine, and secant. How many of these 4 do we need to rewrite? If you understood yesterday's lesson, then you'll know that we need to rewrite only 3 of them, the ones that are not already sine and cosine. So all these 3 we can rewrite. But actually, since we're only working on one side, let's just do the ones on the more complicated side. So tangent is sine theta over cosine theta. Cotangent is its reciprocal. It's cosine theta over sine theta. And all that is being divided by cosine theta. The right side, I'm going to keep it the same. So you might be thinking, oh my gosh, this is getting too complicated, too fast. But wait, look carefully. What can we do on the top? Yeah, the cosines are going to cancel. What else? The sines are going to cancel. So what did the entire numerator turn into? And don't you dare say 0. When nothing is left over, we're left with a 1. So my next step, all right, instead of the numerator, we have now 1 over. The denominator is still cosine theta. And the right side, I haven't touched it yet. And now we are done. 1 over cosine, we know that that's secant because the reciprocal of cosine is secant, and it was in our notes yesterday. If you didn't know that, you best have your notes out. Okay, you are done. For those of you who want the challenge, go ahead. Here's a bonus problem for you. feel free to come up with as many ways of doing it as you like. The more, the better.